If you can do this problem, you'll be fine. So, when we are dealing with quadratics, I literally just need 5 minutes, and you guys are going to do some review. There are 3 things we look for. What are the 3 things we need when we're dealing with quadratics in terms of how to graph them? We need to find the vertex. We need to find the axis of symmetry. And then the other pretty important thing is the zeros. Okay? So I'm going to kind of show you with the same problem that there are 2 ways to find these 3 things. And when I give you the test Thursday, I'm going to let you choose whichever way you like better. So there's not always one particular way you have to do it. So I'm going to show you there are 2 ways. You can either factor the trinomial, or you convert the factor, or you can convert it to vertex form. Okay? So this right now, what I'm about to show you is nothing new. It's just kind of a compilation, a review, and put together everything we've learned. So if the quadratic that I start with is x squared minus 12x plus 35, you look at this and you say to yourself, I need to find these 3 things. How do I want to go about doing that? Okay? I'll start with the vertex form here, converting it, because that's what our most recent lesson is. So if you go with, which is completing the square. So you're using completing the square to do this. All right? So that process was, if you remember, group your x squared and your x terms together, right? And then if it doesn't have an x in it, then you leave it there. Now, to complete the square, remember, 12 is what something got doubled to get 12. So let's find half of 12, which is 6. And then you need to square 6, and you get 36, right? But what you add on the inside, you need to subtract on the outside. So watch. After you complete a square, every time, the next thing you do is factor it. Question? Will you shut that door, please?
Is it still just 6?
Say that again.
It's a negative 12, so is it still just 6?
Yes. Yeah, I'm glad you asked that. Somebody else said that. This negative 12 is not, the sign of this has nothing to do with that. You're always going to put a plus there, okay? So now we factor. And we factor this into x. That sign goes there, and the square root of that. So this factors to that. And then 35 plus a negative 36 is a negative 1, right? Okay, remember, I'm looking for 3 things. Your vertex, your axis of symmetry, and your zeros. So, I can do what now that it's in vertex form? Find the vertex, which is 6 comma negative 1. If I know the vertex, I know the axis of symmetry, right? It's just not 6. X equals 6. It's an equation. It's a line. Now, I want you to stop and think about this. If you know the vertex first, how can you find the zeros? Not just yet. Yeah.
Add 1 to both sides.
Yeah. So basically what Nasser said is solve for x. Because aren't those the zeros? So what you're doing is instead of making it y equals, you're taking the x minus 6 squared minus 1 and making it equal to 0. Ready now? So let's solve this for x. Add 1, like he said, to both sides. That leaves you with x minus 6 squared equals 1. Take the square root of both sides, which a square root under a square basically is just what's in there. And the square root of 1, bless you, is positive or negative 1, right? So then we have the x minus 6 equaling a positive 1 and the x minus 6 equaling a negative 1. So watch. Oops, I'm doing the answer. So x is going to equal 7 or what? 5. Okay. So my zeros are 7 and 5. Don't put a parenthesis around them. It's not an ordered pair. So I went through completing the square. I've used the vertex to find the axis of symmetry. I solved for x and I found my zeros. Right? Okay. Option 2. Go ahead.
On the outside, there's no other number.
We're here?
Yeah.
Well, there's going to have to be, because the problem they're going to start you out with is going to have that 35 there that I'm asking, because it has to be a trinomial for us to start with. If the one in the book doesn't have that there, it basically is just asking you what is that number, and it's not asking you to go through the whole process and put it in vertex form. They're literally just asking you to complete the square, and all they want to know is 36, like on the homework. Okay. So now watch, guys. If you look over at the exact same problem with the exact same goal of finding the vertex axis of symmetry and zeros, you might look at that and go, I'm going to factor it. Piece of cake. Almost done, Brad. So if I look at this and say I can factor it into an x and an x, a positive product with a negative sum means a negative and a negative. What are two numbers when you multiply them gives you 35. Add them gives you 12. 7 and 5. Okay? So now one of my zeros is 7 and one of my zeros is 5. Isn't that what we got over here? And I know what you're thinking. You're thinking, holy cow, it took me all of this just to get to the zeros when I just got them this way. Okay? We'll talk about that in a second. So I need my vertex, I need my axis of symmetry, and I need my zeros. So right now I have my zeros, but now I want you to look at what happens. When you find your vertex first, you got to go through this process to find your zeros. When you find your zeros first, what process do you go through to find the other two? Do you remember? These are my zeros. And my zeros are here and here. So how do I know what my axis of symmetry is? How do you find your zeros, guys? Billy? Yes, she said you would add them together and divide them by 2 because that's how you find halfway. So it's kind of easy because halfway between 5 and 7 is 6. And now that I know that's 6, I know that this is 6. And the only thing I have left to do is find my y. And to find that, I say y equals 6 squared minus 12 times 6 plus 35, which is 36 minus 72 plus 35, which is negative 36 here, plus 35, which is where you get negative 1, and now I want you to look at that, and it's the exact same thing. So, last 2 minutes here. Why would I ever go through all this work when I could just do it this way? Yes, because sometimes the quadratic equation that you're given is not factorable. And you have no choice but to complete the square and convert it to vertex form. So, on your test, you're probably going to have a nice mix of both. And you can choose. I heard somebody last hour say, you know what? I just want to do it this way every single time because this way makes sense to me. Then you go right ahead. Okay? Somebody said, I like factoring. I'm going to do it this way. Well, that's great. You're going to do it that way for the ones that factor. What are you going to do for the ones that don't? So it's kind of like you need to know both, right? If it's factorable, save yourself a little work. If factoring was rough for you, then you may want to go this route. Okay? So,